Yes, ma'am. You're audible.
Okay. So today's session for week 9, right? So let's do a little summary and then we'll do the practice assignment. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay. So week 9 is about graphs, right? So before we go to graphs, let's do a little recollection of all the types of different data containers we've learned about so far. So first is lists. So what is a list? List is a sequence of values. Can be any type of values. There is no restriction, integer, character, string, whatever you want. No random access is allowed. You have to access according to the index. And for value at position I, start at the beginning and scan I minus 1 elements, right? Because this is zero-based indexing. So index starts from 0. Then list, after list, we learned about dictionaries. So dictionary is a key value pair. So every entry in a dictionary is a key value pair where keys are unique, value can be duplicate, right? Dictionary also supports random access because you can directly access a key and get the corresponding value.
Excuse me, ma'am.
Yeah.
This random access, I am just trying to confirm in dictionary. I can understand if I give a key, any key, I will give I will get a value. But in list also, if I give any index, I will get a value corresponding to that. So how does it
No,
make difference?
if you're searching for a particular value in a list, you don't know the index. In that case, you cannot randomly access it, right? You have to start from the first index and then keep on searching with every element. You have to do the matching.
Okay.
Okay. Then next we come to matrix. So in uh, CT, when we talk about graphs, we will be implementing graphs using matrices, right? So a graph is usually what? It is a collection of nodes and edges, right? So there can be nodes like this A, B, C, and they're connected amongst each other. Might be like this, right? So this is not a fully connected graph. There is no path from B to C, but there is a path from A to C and A to B. Or since this is not directed, I can say that there is an edge between the nodes A and B and A and C. But this representation can also be done in the form of a matrix. So this matrix, how we implement using lists, right? That's what we have to learn. So a matrix has what? Two things, row and columns, right? So it is a two-dimensional table. So if you have m rows and n columns, that means your matrix it is an m cross n matrix. That's the order, right? So random access, how we can access an element in a matrix? That is, we can just give the row index and the column index and we can access that element, right? If we have the indices. So by convention, rows and columns are always numbered
Excuse
from
me,
0.
ma'am.
Yeah.
I mean the matrix row column shouldn't be accessed like third bracket then I comma j.
No. I is for matrix, I is for row, J is for column because this is a nested list. Okay, this is list of lists.
Okay.
So I represents your row index, J represents your column index. So if I have a matrix like this, let's say, yes, I have a question.
Ma'am, you said it's a nested list, but in the lecture it was a nest of dictionaries.
Okay. Nested dictionary, where have you seen in some question?
Or in the period assignments.
Okay. It was given in form of dictionary, right?
Yes, ma'am.
Okay. So that is also one implementation I might do in terms of dictionary. Nested dictionary also you can use. But usually the matrix representation is done using lists. If I encounter such a question, I'll show you how to do it using dictionaries also. But basically we do it using lists. So if you have a matrix like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is the order of this matrix? How
3
many
cross
rows, how
3.
many columns? 3 cross 3, right? So if I now want to implement this in terms of lists, then it will be 1, 2, 3. First element, that is first row. 4, 5, 6, second row. 7, 8, 9. This is the third row.
Excuse me, ma'am.
So this is, yeah,
Each row of a matrix is a sublist of a main list.
yes, list implementation, where every element, that is every list that is nested, is one row of the matrix.
Okay.
Okay. So by convention, we will start the indexing from 0 only. So if I say that I have m rows, that means the index will start from 0 up to m minus 1. N columns means 0 up to n minus 1 columns. Right? That is the range of ij values. Now, how can we implement this? What is the code? So here we are saying dictionaries also support random access. Here, what have we used? Dictionary or matrix? Okay. So they are using a mixture of list and dictionary, right? So how can we use that? This is also one way of implementing matrix. Let's see. So dictionaries support random access, as we saw, that we can directly give the key and get the value, right? So if we create a nested dictionary, so what is happening here? Since they're not using this concept, let's not use it. Let's use nested dictionary. So if instead of list, if I want to use nested dictionary, so there will be an outer dictionary and the nested inner dictionary. So outer key corresponds to the rows, inner key corresponds to the columns. Okay. So create matrix is a procedure where we are implementing that. Now outer key corresponds to rows, means first we create a matrix. This is an empty dictionary called matrix, right? Now I is equal to 0. So I is our representative for rows. So while I is less than rows, that means if my matrix is supposed to have, let's say, m rows and n columns. So as long as I is less than m, what will we do? We have to create the matrix. So for matrix of I, we will implement a nested empty dictionary. That means I is what? I is a key of the outer dictionary, right? So let's say I have a 3 cross 3 matrix I want to implement. So here my m and n both are equal to 3. So first your matrix is an empty dictionary. Then we start with I is equal to 0, right? Now as long as I is less than 3, we can execute this loop. So what is the first iteration when I is equal to 0? This is first iteration. Now matrix of I, that means matrix of 0. So this is the outer dictionary key. Against that, I have to give a value, right? Key value pair. So what is that value? That value is an empty dictionary. Again, j is equal to 0. So now in a row, there will be how many columns? As many columns as your question specifies, that is here n is 3. So 3 cross 3 matrix means 3 rows, 3 columns. That means every row has 3 different columns. So we have to initialize j to 0. Then again, there is a nested loop. So this nested loop is to create the columns, right? So how long will this run? As long as j, that means in our example, since we want 3 rows and 3 columns, so as long as j is less than 3, this will run. What is it creating? Again, let's say nested first iteration. So till now, I just have one key of the outer matrix, which is 0 for the first row. And we have an empty dictionary initialized as the value. Now, inside this empty dictionary, we have to fill in the columns. So there are 3 columns. So j value again starts with 0. 0 is less than 3. So valid iteration. Matrix of ij means matrix of 0, 0. This is first row, first column. There we assign the value 0. So initially I am creating a matrix with all values initialized to 0. Then j is incremented, j becomes 1. So second nested iteration, j is 1, which is less than 3, again valid iteration. So I remains 0, j becomes 1. This is first row, second element, second column. That is also initialized to 0. Again, next one that we go to is third iteration. J is again incremented by 1. So j is now 2. third nested iteration, j is 2, which is again less than 3. So now last column of first row, that is row 0, column 2, again 0 value is inserted. So the first row of the matrix is now created. All three zeros are there. How does it look like? This is my nested matrix dictionary. This is the first row I have created, 0, 0, 0, right?
Hmm.
So,
Ma'am, can you repeat line number 11?
yeah. Which line? Tell me the line itself.
Ma'am, I is equal to I plus 1.
Yeah, this one we haven't come to yet. Okay, we are just doing this nested part. First, this while loop is going to execute. Then we come out of the while loop and continue with the next iteration of the outer while, right? This is one complete iteration of the inner while loop. So for row 0, first we have to populate the matrix with all three columns. So all three j values, 0, 1, 0, 1 and 2. First column, second column, third column, all of row 0. Next, once this is over, now your j value is incremented to 3. So 3 is not less than 3. So now we come out of this while loop and increment I. So I started with 0. Now I becomes 1. Again, the same iterations will go on. So now for row 1, you're going to create one more empty matrix, right? One more empty dictionary. So mat of 1, another empty dictionary is now initialized. In this empty dictionary, again, you start with J0 and go until J becomes 3. Then you will stop. That means 0, 1, 2, 3 J values for 3 columns. So like this, you have populated for row 0, row 1, and again for row 2. As soon as I becomes 3, that means after we have populated row 2, then I is equal to I plus 1, I will become 3. So here the condition will be invalid now because we want 3 rows. So 3 not less than 3, so you come out of the outer while loop. So now your matrix is created. So return matrix. Now the matrix that you created is fully populated, but all entries are 0. Right? Up to this much is it clear for everyone? Any doubt? So IJ. So when I say IJ, so what is the, actually tell me what is the structure, right? If this is my outer dictionary. So first row is the first inner dictionary, right? What is the key for that? 0. See, I started with 0, right? So outer key is 0. Again 0, there is a nested dictionary, which is the first row. Now, what are the key and values inside this nested dictionary? One for column 0, where I have given value 0, one for column 1, again value 0, one for column 2, again value 0. Similarly, for row 1, same thing, row 2, same thing. So this is the structure of your dictionary. It is a nested dictionary, matrix structure. So you have implemented, you have created a matrix. So this create matrix procedure will be used later on also. Okay. So you want to create a matrix, you call it my matrix, and inside that you call the create matrix procedure with the number of rows and columns you want. So it will create a matrix of that order. Okay. Now, how do you process matrix? So to process a matrix, we need to know the row and the column, right? We need both of the indices. So typically we need to process all elements either by row or by column. So for each row I of my matrix, for each column j of my matrix, do something with my matrix ij. That means if I have the row and column specified, I can get to a particular value in the matrix. That is value present at row 2, column 3. That is a individual value. So that's how you can address any value in a matrix using these two keys, right? I is the key for the outer dictionary, which represents row. J is the key for the inner dictionary, which represents columns for that row. So we'll write it something like this. So iterating through the rows, row indices keys of outer dictionary, column indices keys of first or any row. So for each are in keys of my matrix. So my matrix is the actual dictionary, the entire dictionary, the outer dictionary. It's called my matrix. So what are the keys of my matrix? Let's say uh, my matrix is an n cross m matrix where n is the number of rows, m is the number of columns. So what are the keys of my matrix? Should be able to tell this. What are the keys of my matrix? That is the outer dictionary. What do the keys represent?
Rows
Rows.
and columns.
Only rows. My matrix keys are only rows. Now for a particular row, if I say row 0, that is my matrix of 0. Against that, there is the nested dictionary which represents the columns. So for each key in keys of my matrix X, take this as example. This matrix that we created. Here, what are the keys of this matrix? Let's call it matrix M. What are the keys of M?
0,
Tell me all the keys.
0,
0,
1, 2.
1, 2.
0, 1, and
0,
2.
1, 2. 0, 1, and 2. Now, if I say, what are the keys of M of 0?
0, 0, 0.
Keys. Those are values.
Oh, sorry.
0, 1, 2.
0, 1,
No.
2 again.
These are the keys, right? Nested dictionary keys. So M of 0 means 0th row. And what are the keys of that dictionary? That is this dictionary, 0, 1, 2. So that's how you approach each and every element using both row and column indices. That's what is given here, right? So for each R in keys of my matrix, that represents the rows. And once you have chosen a row, for that you can now go through all of the columns. So for each C in keys of my matrix 0, that's why this column entry is the nested loop, right? Now how to process? Okay, one more thing. Keys of D produces a list always, right? Keys is a function which always gives you a list of keys of a particular dictionary in arbitrary order. So you can sort it if you wanted it ascending order. So sort of keys of D's will give you keys in ascending order. So they're saying that to improve readability, that is instead of writing this whole thing, sort of keys of my matrix, sort of keys of my matrix 0, to improve the readability, we can just use rows and columns instead. So the functions are now called as rows and columns. So for each R in rows of my matrix means now we will be accessing one by one the rows of my matrix or the keys of my matrix in ascending order. Then again for each row, you can now access the columns also in ascending order. Right. So rows represents this sort of keys and columns also represent sort of keys. So instead of writing the whole thing, you can write this. So summary, what we saw in this is how to create a matrix, right? You can access any random element by its row and column index. You can implement matrix using nested dictionary. What are the iterators we are going to use? One row-wise iterator and one column-wise iterator, that is R and C. Okay. Now why we are learning matrix is because our end goal is to represent graphs with the help of matrix. Now, one more summary slide I want to discuss before going to the practice, because all of this has already been discussed in last session, so I'm not going to spend a lot of time on this. So now let's take an example like mentoring. Okay. So we want to assign mentors to students. So mentors are also students. A student A can mentor a student B in a particular subject. What is the condition? If A has higher marks, but not too much higher than B. That means A and B, if we want A to mentor B, then the difference between marks of A and B should fall within a particular range that is given. So difference should be between 10 and 20 marks. It should not be less than 10 marks. It should not be more than 20 marks. So 10 and 20 included. Create a dictionary for marks in each subject. So to assign the mentors correctly, first we have to know what are the marks of students in each of the subjects, right? So for example, if I want to find out what are the marks of students in mathematics, so math marks is a variable inside which I'm calling a function called read marks of mathematics. Mathematics is the parameter. So now what does procedure read marks do? So this is the procedure definition. So this procedure accepts any subject, can be maths, physics, chemistry, anything. Then it creates an empty dictionary called marks. Then it has a while loop which iterates through all of the cards This is in the scores data set because we're dealing with marks and students, right? So this is scores data set. So while table 1 has more rows means we now go through all of the cards in the scores data set. So you read a card and then you create an entry in the dictionary. So the first card you read, let's say it is sequence number 1 and the subject corresponding, since we're talking about mathematics, let's say first entry is for student with sequence number 1 who scored 70 in math. So in the dictionary, there will be in marks dictionary, there will be an entry like this 1:70. Then like this for all of the students 2:90, something like this. For all of the students, there will be one entry created. So once the entire marks dictionary is populated with the data of all students, then we can return the marks dictionary. So this is what, this is just a record of a student has scored what marks in a particular subject. So like this we can find for physics also, chemistry also. Now let's take for mathematics currently. So we are only interested in finding for mathematics. So we created the dictionary. Sequence number of student is to marks stored. Now we want to create the mentoring graph. That is who can mentor who, right? So create a mentoring graph for a subject represent as a matrix. So Mij is equal to 1 if there is an edge from I to j. What does this mean? And if there is no edge from I to j, then it is, the entry should be 0 in the matrix. So this means that, yes, you want to ask anything? Gautam, yeah, you want to ask something?
Can you please repeat again?
Which part?
Mentoring from student A.
Yes, so student A, we are trying to form a graph among the students. The graph should represent the mentoring, right? Mentoring means that student A can mentor student B in a particular subject. What is the condition? That student A should have higher marks than student B in that particular subject. Again, the marks difference should not be too big or too small. So marks difference between A and B should be between 10 and 20 marks. That is, A should have scored higher than B, but the difference in marks should be between 10 and 20 marks. Right now, we are trying to create that mentoring graph. So we created a dictionary for marks in mathematics, where each dictionary entry is a sequence number of a student and corresponding value is the marks scored by student in that subject. So here it is saying that create a mentoring graph for a subject represent as a matrix. Mij is one entry of the matrix, that is ith row and jth column. So that entry, if it is 1, that means there is an edge from I to j. And if the entry is 0, that means there is no edge from I to j. So what does this mean? That if there is an edge from I to j, that means student I can mentor student j. And if there is no edge, that means I cannot mentor student j. So how to represent that in the form of a graph, which we represent as matrix? So see this procedure called create mentor graph. So this takes mark dictionary that we created, right? This is the dictionary that we created for a particular subject like math marks. So you pass that as your parameter. Now n is the length of keys of marks. So if I have 30 students, what will be the length of keys of marks?
30.
30.
30. Because for each unique student, we have one entry, right? Again, n is storing that value. Now, mentor graph is a variable inside which I'm calling the create matrix procedure with n cross n. That is n rows and n columns I want in my matrix. So now mentor graph is what? What is mentor graph representing? After I call the create
Which
dictionary, create
students
matrix.
can mentor with students?
No, I'm just asking till now. Like in this line, mentor graph, inside mentor graph, I've called create matrix and I've passed n,
It is
n
a
comma n as
matrix
parameter.
in which all elements are 0.
It is an n cross n matrix where all elements are 0, right? Now we want to access the element. So I need the row index and I need the column index. So for each I in keys of marks. So each I in keys of marks means each individual student sequence number, those are the keys of marks. And again for each j in keys of marks. So for one student I with sequence number I am going to compare their marks with another student having sequence number J. Right? Because what are the rows and columns of this matrix? Sequence numbers itself. So now if I check that marks of I minus marks of J, now I'm getting the difference between I and J's marks. So once the difference is calculated, it is stored in ij marks difference in this variable. So what is our condition? That if I has to mentor J, then the condition should be that difference between I and J's marks should not exceed 10 and 20. So if ij marks difference is greater than equal to 10, that is, it is including 10 and greater than 10, and the difference is also less than equal to 20, that is including 20 or less than 20. So it falls between 10 and 20, including 10 and 20. Then your condition is valid. That means I is eligible to mentor J. So mentor graph ij entry in the matrix will now have the value 1 instead of 0. So wherever we see the value 1 is stored in the mentor graph, it means that that particular column ID is being mentored by the particular row ID student. Understood up to this?
Yes, ma'am.
Okay. So now then you return the mentor graph. So like this, you can create for any particular subject you want. You can create the mentor graph. Now pairing of students in study groups. So it is saying that a student A can mentor a student B in one subject and B can mentor A in another subject. That means if A has, let's say, scored more than B in maths and the criteria is valid that the difference in score doesn't exceed 10 and 20. It can also happen that B has scored greater than A in chemistry, where again the difference of B and A's marks are between 10 and 20. That means A can be a valid mentor of B in mathematics and B can also be a valid mentor of A in chemistry. Right? So study groups, so they're taking the subjects maths and physics. So we want to create mentoring graphs for each of these subjects. So again, the same procedure we have to follow. First, create a dictionary for mathematics marks, then create a dictionary for physics marks. Those dictionaries are stored in these two variables, math marks and physics marks. These are just data of student marks in both the subjects, right? Then you create the math mentor graph and the physics mentor graph. So create mentor graph procedure. Again, you have to call with the particular dictionary. This is the last procedure that we saw, this one. So this will create the corresponding matrix. One for math, one for physics mentors. Next, we have to use the we have to use the mentoring graphs to pair off students. So how are we doing this pairing? Right, that means what is a pair? Where if A and B, that means if I and J are a pair of students, so they are a valid pair when I mentors J in one subject and J mentors I in another subject. In that case, I and J can be called as a pair. Right, so we are trying to find all of those pairs. So up to this we have created the mentor graphs for both subjects, maths and physics. Then you initialize another empty dictionary called paired. Now for each I in rows of math mentor graph. So what does each I represent? Each student sequence number, right, in math mentor graph. Similarly for each J in columns of math mentor graph. These are also student sequence numbers. If math mentor graph Ij is equal to 1, this means that I can mentor J in math subject, right? That's why the corresponding entry is 1. And we also check if physics mentor graph Ji is equal to 1. That means in physics subject, J can mentor I. That's why in physics mentor graph, Ji entry is 1. So if both of these are true and not is key paired I and not is key paired J, that means I and J are not already keys of the paired dictionary. That means they are not already paired with some other student. If I and J are not paired with some other student, and these two conditions are true, that means in total, if all 4 conditions are true, then we can set these two as a valid pair. That means paired of I will have J. That means I and J are now 2 keys of dictionary paired, where I is paired with J, J is paired with I. Yes. What's the question?
Ma'am, so if I is already paired with someone, the J
Yeah.
cannot be
No.
paired with I, right?
Then you cannot pair. That's why these two are checked.
So if J is not paired with anyone else also, so J remains unpaired, even though he is very
Yeah,
much capable of getting
because
paired with
all
I.
pairs have to be of unique students.
Yeah, I get. Okay.
Okay. So that's how you can pair off every student with another unique student, but make sure that that student is also paired with this particular student only. If I is paired with J, then J also has to be paired with I only, no one else. So like this, we can create the paired dictionary. Next, our issue we have to tackle is popular students. So a student who can be mentored by many other students is a popular student. That means, let's say I is a student who is mentored by a number of other students. So I becomes a popular student. So we have to create mentoring graphs for all three subjects to check that who are these popular students, right? So for math marks, physics marks, and chemistry marks, we have created these three dictionaries. These are just the read marks. That means these are just the subject-wise dictionaries of student sequence number and marks. Next, math mentor graph, physics mentor graph, chemistry mentor graph. For all three of these, you now create the mentor graphs for maths, physics, and chemistry, that who mentors who in each of the subjects. Once you have these three prepared, these three matrices are prepared, physics, chemistry, math. Now we want to count what? We want to create mentoring graphs for all three subjects and count incoming mentoring edges for each student. So when is a student a popular student? When he is mentored by many other students. That means if student I is popular, so there should be many other students from which there are incoming edges to I, right? Because what did I say? That if there is an edge from I to J, it means that J is being mentored by I. So if there are multiple incoming edges to I, that means these are all mentors of I, right? So we have to count these incoming edges for each of the students to find out who are the popular students. The students who have the maximum number of incoming edges, they are the popular students. They are the ones who are mentored by many students. So first we introduce a dictionary called popularity, which is empty dictionary. Now for each I in keys of math marks. That means each I in keys of math marks, each sequence number of unique students. So I represent sequence number of unique students. Popularity of I is equal to 0. That means initially in popularity matrix or popularity dictionary, the keys are what? All of the unique student sequence numbers and corresponding values are all set to 0, right? Since in every iteration that is what is happening. So let's say for the first iteration of the outer for each block, let's say the student sequence number 1 is now set to 0 in this popularity dictionary. So for key 1 in this popularity dictionary, for key 1, I have placed the value 0. Now in the nested for each block, for j in keys of math marks, that means one more student sequence number is now picked. If math mentor graph ji is equal to 1, from here what can I say about I and j?
J is mentor of I.
J is mentoring I, right? In mathematics. Since in math mentor graph, ji is equal to 1. So
Ma'am,
in popularity,
okay.
see, I is the student who is being mentored. He is not the mentor.
I get that.
So if I find such a J who is mentoring I, in that case, in popularity matrix, the value of I will now be incremented by 1. That means we have found one mentor for this particular student. So now change this from 0 to 1. So sequence number 1 student is mentored by one person. We have found such a person. Again, check in physics mentor graph. If for the same I and J, if J mentors I in physics also, then again increment popularity by 1. Popularity of I by 1. That means you have found one more mentor. See, this person I is being mentored by the same person J. Okay. But what am I saying? That in two different subjects. So they are being counted twice. This is the same person. Again, if chemistry mentor graph, that means if J also mentors I in chemistry, then again increment by 1. So it might not be true for all of these cases, right? One person J might be mentoring I in only one subject. That might be true. So in that case, for this single J value, only one increment will happen. Yeah.
Ma'am, but we are learning the loop with math marks, right?
No. See,
So it
we
is
are just
limited.
taking the keys. We are just taking the keys from math marks. Keys are same in all the dictionaries. All are sequence number only. You can take from physics marks also, chemistry marks also.
Okay, okay.
Okay. So one student J can mentor a student I in either one subject or two subjects or three subjects or in no subjects. Right. So according to that, the increments will happen. So once see, for every I, we will go through all the J values. That means for every student, we'll check with all other students. Okay. So like this, for every student I, will find all possible mentors in all possible subjects. That means at the end of execution of this code, for every sequence number of every unique student, we will have found all the corresponding mentors who are teaching this student, who are mentoring this student. So the total number of mentor for every student will have been calculated from this nested for each. Up to this, is it clear?
Yes, ma'am.
So that is done. Now, see, we want to avoid duplicates. That means exactly keep track of mentors for each student and count them. So now they're saying that we want to avoid the duplicates. That means keep track of one mentor only once, right? So what are we doing? See in this code, once you see it, you'll understand. Mentors is now an empty dictionary. Popularity is an empty dictionary. So for J in columns of math mentor graph, again, math mentor graph has columns as sequence numbers only of students. So now for each such sequence number, we create an entry in mentors dictionary. So now mentors of J, and correspondingly we have another empty dictionary. That means mentors is a nested dictionary where the outer keys are sequence numbers of unique students and corresponding values are empty dictionaries. Now in these empty dictionaries, what are we filling? So for each I in rows of math mentor graph. So now you are again picking all the possible I's for each possible J. That means for each student, we are checking with all other possible students. That what is the mentoring relationship. So for each student J, check with every other I. What are we checking? If math mentor graph Ij is equal to 1. That means if I mentors J in math, right? Then mentors of Ji will be set as true. So what does this mean? Mentors dictionary will now look like this, right? Let's say my J value I'm starting with is 1. Okay, and the corresponding I value. Okay, let's say J value is 1 and I value is 2, because obviously a student cannot mentor himself. So let's go to another sequence ID, that is 2. Now for the students 1 and 2. Okay, first of all, in mentors dictionary, as soon as I picked the J value 1, one entry has been created in mentors dictionary. That looks like this. 1, correspondingly, a matrix has been generated as the value. Now for each I in rows, let's say the first I is 2. In math mentor graph, if I see that 2, 1, this entry, that means second row, first column, this entry is 1. That means I can say that 2 can mentor student 1 in math, right? 2 mentor student 1 in math. So how can I represent that in the mentors matrix or graph, whatever you want to call it? So mentors of J and I. So J is 1, corresponding I value is what? 2. And the value should be stored as true. So what does this mean? That for this particular J, this is a mentor who mentors him, right? Again, let's take another I value 3. Maybe this person mentors J in chemistry. So here J is 1, I is 3. If I see that this value is equal to 1 in chem mentor graph, that means that student with sequence ID 3 mentor student with sequence ID 1 in chemistry. So again, there will be one more entry of 3 is to true. So like this, for every individual, we will create one entry. Now tell me something. If this person, 3, okay. If I see that he also mentors particular student 1 in physics, will there be a separate entry for him in the next dictionary? Again, will I write 3 is to T? In a dictionary, is it possible to have duplicate
Two
keys?
is already given there,
No, ma'am.
so
You cannot have duplicate keys. So that is how we are avoiding the duplicates. That means every time we find a mentor, that a person is being mentored by a particular student, we enter their data already. Now, once it is entered that this particular student is a valid mentor of I or J, then next, if I find that this student is also mentoring J in some other subject, we don't need to create a separate entry for that because one entry is enough. It is a dictionary. There should be no duplicate keys. That means this will give you the unique number of mentors, which is what we were lacking in the previous code. Because in previous code, if student I was being mentored by student J in 2 subjects, then we were calculating that twice. But now there will be only one entry. So a student can be mentored by another student in all 3 subjects, but there will be only one entry for that. Right. So here you remove all the duplicates like this. So once this entire thing is over, this nested for each, then popularity of J in popularity matrix that we created will be counted as length of keys of mentor. So what are keys of mentors of J representing? Just this much. What are keys of mentors of J? This is J. These are the keys. What are these keys? 2 and 3, what are they?
sequence number.
What is the relationship? If I say that my J is 1, this is J. What are the corresponding keys? 2 and 3. So who are 2 and 3 to J? What is the relationship between them?
2 and 3 mentor J, and J can mentor 2 and 3.
No. 2 and 3 are the mentors of J. How can I say vice versa? That 1 also mentors 2 and 3? I haven't checked that. That will be present in 2's dictionary and 3's dictionary. Who are the mentors of 2 and 3? This is 1's dictionary. So I can only say for sure that 2 and 3 are the mentors of 1. Right?
Okay, ma'am.
So 2 and 3 are the mentors of 1. So now if I take length of these keys. So for student J, where J value is 1 currently, what will length of keys give me? This length of keys of mentors of J, what does this represent? Number of mentors that J has, number of unique mentors of J. Yes or no?
Yes, ma'am.
Everyone understood up to this? Okay. So popularity matrix contains what? For every individual student, the entry is like this, that for a student I, the corresponding entry is sum n, where n represents the number of unique mentors of the student I. Like this, for every particular student, there is an entry in the popularity matrix, right? So popularity matrix has entries like this. So from here, if I want to know that who is the most popular student, how will I find out? Or there can be more than one.
Comparing length.
Comparing the values, right? Stored against each student. So the person who is being mentored by the maximum number of people, for the student for whom the n is maximum, that is the most popular student. Or if there are more than one such students, all of them are popular students. So this is the end of this popular students problem, right? Next, we have one more problem called similar students. So students are similar if they have similar marks in all subjects. Similar marks means two students I and J. So they have marks in 3 subjects, maths, physics, and chemistry, right? Difference is within 10 marks. That means if I has scored, let's say 60 in maths, J has scored 65 in math. I has scored 70 in physics, J has scored 62 in physics. I has scored 80 in chemistry, J has scored 88. So are I and J similar students?
Yes, ma'am.
Yes.
Because each of the subject marks differences are between 10 marks, within 10, right? Not exceeding 10. So again, we create the dictionaries with marks in each subject. For maths, physics, and chemistry, these are just sequence number is 2 marks in every subject. Now, what is the similar students code? Again, that's similar thing. You have to check the difference. So procedure, create similarity graph. So now we want a similarity graph. What is the similarity graph? That between 2 students, if there is an edge, it means that those 2 are similar students. So for similarity graph, we take marks 1, marks 2, marks 3 as argument. What is marks 1, marks 2, marks 3? These 3 dictionaries, maths, physics, and chemistry marks. Right. N is what? Length of keys of marks 1. Because all of them have the same number of keys. Because student number is same in all 3, right? All students are there in all 3 subjects. So take the length of keys of any one of these dictionaries. That is your N. That is the number of students. Now in similarity graph, you call the procedure create matrix N cross N. So one matrix is created for called similarity graph. Now again, you have to access the elements. So for each I in keys of marks 1, that is, but pick one sequence number from marks 1. Again, pick another sequence number J from marks 1. See, marks 1 is just given. It is not necessary. You can use any of these dictionaries, marks 2, marks 3, anything. Okay, because we just need to access the sequence numbers. That's it. So pick any 2 sequence numbers I and J, and for every IJ, what you have to check is marks 1 of I and marks 1 of J. Let's say marks 1 represents maths, marks 2 represents physics dictionary, marks 3 represents chemistry dictionary. So marks 1 of I minus marks 1 of J is absolute difference of that. That means this is the absolute difference between marks of I and J in mathematics. That is being stored in IJ diff 1. Again, difference between marks of I and J in physics. Absolute value of that. That means we don't want positive or negative, so we're taking absolute value. Again, that difference is stored in IJ difference 2. In IJ difference 3, we are storing the absolute difference between marks of I and J in chemistry. So all 3 differences are stored. Now, what is your condition? Difference should be within 10 marks. So just a simple if statement. If all 3 differences are within 10 marks, that is less than equal to 10. See, IJ diff 1 less than equal to 10, and IJ diff 2 less than equal to 10, and IJ diff 3 less than equal to 10. If all 3 are correct, then we can say in similarity graph, between I and J nodes, there will be an edge. That means this IJ entry will be 1 in similarity graph. So whenever in similarity graph, you see that for a particular row I and a particular column J, the corresponding entry is 1. It means I and J are similar students. Is this procedure clear? Any doubt? Okay. So that's it. Now we are going to start.
Can you repeat popularity graph? Because
This one.
yeah.
So popularity was initially, it is not a graph. It is just a dictionary. Okay. Popularity is an empty dictionary. Now for popularity dictionary, what are the keys of that dictionary? From this code, what can you see? What is J? Sequence number of a student.
Yes.
That is the key.
Which is the
So
dictionary given is?
popularity is a dictionary. Mentors is also a nested dictionary.
Okay.
Okay. Mentors dictionary stores what? For every unique student, there is a key in Mentors dictionary. Corresponding value is another dictionary, which is the nested dictionary. That contains what? The information about who are the unique mentors of this particular student. Like for student 1, mentors are 2 and 3. Okay. So length of keys of mentors for a particular student gives what? Number of unique mentors for that student. So in popularity dictionary, for every student sequence number J, we take that as the key, and correspondingly, what is the value? The number of unique mentors of that student. So popularity dictionary is what? Just the count of unique mentors of every student.
Can you like explain by example mentors and popularity?
That's what I did when I explained this entire code, right? This is the dictionary. This is the mentors dictionary. Like this, see. In mentors dictionary, there will be an entry for every unique sequence number of a student. So for student with sequence number 1, that's an outer key. Against that, there is another dictionary. This dictionary is supposed to contain who are all the unique mentors. Let's say 2 is a unique mentor of student 1. So 2 is a key of in a dictionary, corresponding value is true. Again, 3 is a valid mentor of student 1. So 3 is a unique entry, against that value is 2. True. Again, 5 also mentors 1. So against 5 also true value is stored. So if these 3 are the unique mentors of 1, right? Then what is the count of mentors of 1? 3.
3.
So in popularity dictionary, against this student 1, what will be the count stored? 3. Like that, for student 2 also, you have one more dictionary having all mentors of student 2. Up till student n, you have a dictionary. So the inner dictionaries just represent unique mentors for each student. So we take the count of that, and the count is stored again in popularity. So popularity also have same number of keys, right? 1,
Yes.
2, up to n. And the corresponding value represents what is the count of unique mentors for this particular student. Clear?
Yeah.
Yeah, what's the question? Any other question from this part?
Yes, ma'am.
Yeah, tell me.
Can you repeat this similar students?
It is exactly like the previous one. See, now we just the
Ma'am, can you once go through the popularity student steps, because I didn't understand, so I seem to get confused actually in that steps wise.
which part of the code? Popularity comes only at the end. First, you have to create the mentors. From there, you have to calculate popularity.
Yeah, yeah.
See,
Like
I will go through this code one more time. Just listen carefully, okay?
Okay.
Mentors and popularity are initially two empty dictionaries, right?
Yes.
My goal is that in mentors dictionary, I will store a unique entry for every unique student. So the keys of mentor dictionary are unique sequence numbers of students. Against every unique sequence number, I'm storing another dictionary. So mentors is a nested dictionary, basically. So what is each nested dictionary storing? Like for student with sequence number 1, the corresponding value is a nested dictionary. In that dictionary, I'm trying to store who are the unique mentors of that student. Okay, so
Yeah.
how am I storing that? See, first for each j in columns of math mentor graph, that means j is what? A unique sequence number.
Yes.
In mentors dictionary, first it is empty. Let's say I'm doing the first iteration. So j is 1. Okay, first j I have picked for each j in columns of math mentor graph. Let's say j is 1. So first I have to create an entry. See, mentors j and corresponding value is a nested empty dictionary. So corresponding to 1, there is now an empty dictionary. Okay, up to this.
Yes.
Next, you have to pick one more student. So for each I in rows of math mentor graph, let's say the next I is 2, because there is no point in comparing a student with himself, right? If I take I1, a student cannot mentor himself. So I'm taking an example of another student. Let's say student 2, when I value is 2. So then I check. So remember, J is 1, I is 2. So what am I checking? First, I'm checking if in math mentor graph, IJ entry is 1. If IJ entry is 1, what does this mean? That I mentored student J in mathematics?
Yeah.
Correct? So if this is satisfied, then in mentors dictionary, you will create an entry for this I. and the corresponding value will be stored as true. That means what is the new update done? That for student 1, I have found a mentor with ID 2 and the corresponding value is true. Okay.
Okay.
Now let's say you find that in physics also, this particular student I, that is sequence number 2, is also mentoring student 1 in physics also. So for that also you are supposed to create a entry, but will that be a separate entry? That is this entry only, right?
Yes.
Because inside a dictionary you cannot have duplicate keys. So for every mentor, only one entry should be there, no matter how many subjects he is mentoring this particular student in. Okay. That means for every such student J, what does the nested dictionary represent?
Unique mentor.
Number of unique mentors, right? All the unique mentors are stored here. So if I, let's say for student 1, if I take, let's say there are more mentors, 3, true, 5, true. So for 1, there are these 3 mentors, unique mentors. So now in popularity matrix, see at the end, once the mentors graph has been completely populated for every student, then I come to popularity matrix. And what am I checking? That means for every iteration, right? See, where is this popularity J statement present? In the outer for each block. That means for when all the inner for each iterations are completed for a particular student. That means for student J, when I have found out total how many unique mentors are there, and they are all now present in the dictionary. Then in popularity dictionary, I create an entry for this same student J, that is 1. And I take the corresponding value as length of keys of mentors of J. So what are the keys of mentors of J here? 2, 3, and 5, right?
Yes.
What is the length? 3. So 1 corresponding value is 3. So what does popularity matrix represent? For every unique student, how many unique mentors are there? Now is it clear?
Yeah, yeah. Very mostly clear.
Okay. Just go through this code one more time. Take a sample set. It will be more clear to you. Yes. Similar students, right?
Yes, ma'am.
Look, now everything is same, just the condition has changed. So now for two students to be similar, what was the example I took? This example that two students I and J, if they are similar, what do we have to check? That their difference of marks is not more than 10 in any of the subjects, right? Difference is within 10 marks. So I took two arbitrary students I and J. Let's say they scored 60 and 65 in math, 70, 62 in physics, 80 and 88 in chemistry. So are any of the subject wise differences exceeding 10? For I and J, for each subject, are any of the differences exceeding 10?
Yes.
How is it exceeding? 60 minus 65 is 5.
No, ma'am.
None of them are exceeding, right? That means I and J are similar students. So this is what I'm trying to find out, that who are the similar students. For that, I'm trying to create a similarity graph. So in similarity graph, if ij is equal to 1, this represents that I and J are similar students. If it is 0, that means I and J are not similar. Keeping this in mind, now create it. So what is the procedure? Similarity, create similarity graph. It is taking 3 arguments, marks 1, marks 2, and marks 3. What are marks 1, marks 2, marks 3? These 3 dictionaries of maths, physics, and chemistry marks of each student. In N, we are storing the length of keys of any of these dictionary. That means total number of students, basically, that is being stored in N. Now you create the similarity matrix. So you call the create matrix procedure with N cross N order. N rows, N columns for N students. So an N cross N matrix is now created. Now for each I in keys of marks 1 and each J in keys of marks 1, that means 2 individual students I and J. For them, I want to check if I and J are similar. So what I have to do, I first have to find out the difference in their marks in each of the 3 subjects. So let's say marks 1 is the maths dictionary, marks 2 is the physics dictionary, marks 3 is the chemistry dictionary. So for two students I and J, marks 1 I minus marks 1 J. This is what? Difference of their marks in mathematics. And I'm taking the absolute value to get rid of any negative signs. So absolute difference between their marks in mathematics is being stored in IJ difference 1. Absolute difference between their marks in physics is being stored in IJ difference 2. Absolute difference between their marks in chemistry is being stored in IJ difference 3. Now, for them to be similar students, all of these differences should be within 10, right? That's the condition. So if IJ difference 1 is less than equal to 10 and IJ difference 2 is less than equal to 10 and IJ difference 3 is less than equal to 10, if all three are correct, then in similarity graph or matrix, you can say that similarity IJ value should be assigned 1. That means I and J are similar students. So like this, you check for every pair of students, IJ. Is it clear?
Yes, ma'am.
Okay, now let's do the practice assignment. I'll try to do the first half of it. Next half we can do in next session.
Ma'am, this is for week
Ma'am, I
9
have a
or week 10, ma'am.
This is week 9.
But then 4 days after we have to submit the week 10 assignments. Week 9 has already gone.
When is week 9 is already done.
Yes,
Yeah,
Deadline
ma'am.
is over.
we have
deadline
already
is
submitted the graded assignments.
Graded assignment.
In fact, I have some doubts. That's why I close it.
Okay. So graded deadline is over, right? I was told to discuss the practice today. Okay, no problem. See, you have doubts in graded, right? So in Monday session also we are taking on this week 9 only, I think. Was week 9 just started in the last session yesterday?
Week 9 is over.
over, ma'am.
No.
It's over.
No, I am asking in the sessions. In the sessions, how many sessions has been there in week 9?
6, I think.
Today is the second one.
Oh no, you're
Yeah, yeah.
asking about the TA
Yeah, today
sessions.
is the
TA,
second
there
one.
No,
has
no,
been
not TS, not TS session, instructor session. How many
instructor, there
instructor
has
session?
been
Yes, ma'am. Yes.
yeah,
It is
today
the
is the
second.
second one.
Today is the second one, right? So on Monday there will be one more instructor session. So in there, let me ask them to discuss the graded ones because it is already submitted.
Yeah. Ma'am.
I
So,
think the
ma'am,
9 and 10 assignment dates are colliding a little.
ma'am, week 10 assignment last date is 13, ma'am. Actually, 4 days from now. So
Okay.
I had doubts
So
in.
maybe we can
Ma'am,
discuss
if
week 10
we,
in that,
if
right?
we,
Week 10 in
ma'am,
Monday
like,
session.
you can ask the class which is present right now if anyone has doubt in practice
Yeah,
assignment
so
because I
if anyone has doubt in practice assignment of week 9, then only I'll discuss. Does anyone have doubt in it?
I have doubt in graded assignment.
Okay, practice, no one has doubts. You can tell me, then I'll just take those questions from practice. Okay, then let's do the graded since deadline is over. One second, huh? Let me open the graded assignment.
Ma'am, when will session for week 10 instructions?
Yeah, so it was supposed to be next week, but since you are saying that deadline is already on 13th, so I think Monday session we have to take week 10. I'll let them know. I think Piyush sir will take Monday session. In foundation level, I think the deadlines are collided a little for week 9 and 10. Okay, week 10, week 9 graded, right?
Ma'am, I have a question number 13 in graded assignment.
I'm just trying to find all the questions together. One second.
Yeah.
When was the last date for this assignment?
Yesterday.
Yes, Sunday.
Friday. Okay. Let me still check the deadline once. Okay, 8th August. Right. Yeah, which question you have doubt in? GA?
On question 13.
30. Let
Yeah,
me
ma'am.
share my
Me
screen.
too.
Can you see?
Yes,
Yes, ma'am.
13. Is it a part question or a new question? Okay, new question. All right, this one, right? This computer scientist one?
Yes, ma'am.
Okay, let's do it. So, a computer scientist is planning to conduct an event in the city. She has come up with a novel scheme to invite people. So, the host can send out any number of invitations and does not accept any invitation. So, obviously, host doesn't accept an invitation but can send out any number. So, each invitation is represented by a unique text message. That means each invitation is unique in itself, and each invitee can choose to either accept or reject the invitations. There are two options. If an invitee accepts, then he can invite exactly one other person by forwarding the invitation that he received to that person. That is, the invitee can forward the message he received only once. Right. So every invitee that comes can bring at most one more person with them. That's the goal. Now, if an invitee doesn't accept the invitation, he cannot invite someone else. So if an invitation is rejected, it cannot be forwarded as well. Now, if a person receives multiple invitations, he can accept at most one of them. Right. So one person might receive multiple invitations, but only one of them he can accept. All others must be rejected. So this situation is modeled as a graph. So there is a node corresponding to every person who attends the event. Right. So if n people attend the event and attendees are indexed from 0 to n minus 1, then what are the nodes from 0 to n minus 1? I'll have n nodes in total. Okay. So given a pair of attendees, ij, there is an edge from I to j if and only if the following conditions are satisfied. That j was invited by I and j accepted I's invitation. Right? So the graph is represented by a matrix, again, adjacency matrix A, such that A of ij is 1 if and only if there is an edge from I to j. So edge from I to j means that I invited j and j accepted I's invitation. So for the case of n equals to 5, that means there are only 5 attendees. Which of the following is a possible representation of the graph? Question is clear for everyone, right?
Yes,
Yes,
ma'am.
sir.
Let's see the first option. So see, these two are the main keywords that for every branch, for every edge ij, we have to check whether j accepted i's invitation and j was invited by a, right? So we can see an edge from 3 to 4. But there is again an edge from 3 to 0. So can a person invite more than one person?
When
No.
3 works there, so he can.
Sorry, what did you say?
He is the host, ma'am. So he can
Three
invite.
is three is the host. But that should be clearly mentioned, right? So host is also one of the attendees. It is not mentioned anywhere. Okay, for now, let's just say that let's go on with the assumption that 3 is not a host. Okay. Might be a host, but since it is not mentioned anywhere, I'm not assuming that. Obviously, the host will attend the event, but the host doesn't have to
Ma'am,
follow all these criteria, right?
it's written n equals to 5. So does
Hmm.
is host counted in that n or not?
Exactly, because n people attend the event, right? So I think these are the attendees only who the host has invited. So that's why I
Yes.
am not counting host in this n equal to 5. These are just the
Yes,
attendees. Okay.
yes.
So 3 cannot send, that means if 3 has accepted to go, right? If 3 has accepted to go, then 3 cannot send more than one invitation, which 3 is sending here. But now again, there is no incoming edge to 3. So that is also one question. So if someone is attending, then they have to be invited, right?
Ma'am,
This question is a bit
3 can
ambiguous.
send more than one. It's just that
No, see, a person can send, if a person has received an invitation and they accept it, they can only send to one other person. Right. So if there is an edge from 3 to 4 and 3 to 0, it means 0 and 4 are both invited by 3. So if 3 is not the host, then this is not possible. Right. So if I go with the host assumption, then this is okay. That if 3 is the host, then 3 can invite both 0 and 4. Right. And then 0 invites 1, and then 1 invites 2. So this is okay. 3 invites 4, 4 invites 0. So 0 is now getting multiple invitations, but they have to reject, right? If you receive multiple invitations, you have to reject all other invitations except one if you want to go. These are all the conditions that are given. Second option, let's
ma'am,
check.
if ma'am, I insist if we like look at option C directly after A, because I'm pretty sure that everybody thinks B and D are straight away out of the question.
B and D are out of it because there are all these
Why?
incoming edges to 4,
Yeah.
right?
Plus, B and D have like B has one like 0 also invites and 3 also invite, but the host invites.
Right. Okay. So 3 is inviting 0 and 0 is inviting 1.
But 3 is also inviting
Right.
4.
3 is
And
also
one is
inviting
inviting
4.
for
So if
itself.
I take 3 as the host, then 3 can invite 0 and 4. But then host cannot be invited by another person, right?
Yeah.
This
That's what
doesn't
I
make
thought.
sense. So C, if I check, if 3 is the host, then 3 can invite 0 and 4. 0 can invite 1, 1 can invite 2. Now, this is correct, but if I look at option 1,
I think what
uh,
happened in C was that 3 invites 4, but since 4 didn't accept 3, 3 has to invite 0 also. Now 0 accepts it. So now
no,
3
no,
and 0 both
it
can go.
doesn't matter. See, if I send out if I have been invited, I accept it and I send out an invitation, then that invitation is not retractable, right? Whether the person accepts or not, that is not in my hands. But once I send it out, I can retract it. I can give it to another person. So if you are strictly an attendee, you can send to only one other person. Okay. Okay, let's
Yeah.
just avoid all this and see what they have given in the solution. They're saying option C is the answer, right? So
Yeah,
option
there
A,
was
they're saying
also a
in this graph.
condition where, yeah, there's also a condition where the host didn't receive any invitation, right? So 3 must be a host, right?
So that's what they're saying. That means host is included in this N people. I think this is very ambiguous. You should at least mention
The
that
question was very
in,
vague.
yeah,
Yeah, it was very vague.
because from this nothing is clear that does the host have to be included or not? That what is N? I mean, N is attendees, but host can also be as an attendee or not, right? We don't know that. See, in the question statement, let's see once what is given. Yeah, nowhere it is written that host is also called as an attendee.
Ma'am, an option A should also be correct because if like host can invite multiple, then host can invite 0 and 4,
So
but
why they have
4
given
can
wrong?
also
Let's
invite
see.
0.
They're saying node 3 is the host since she is not receiving any invitations. Fine. And is inviting more than one people. So when we traverse the graph, we see that node 0 is accepting more than one invitation, which is against the scheme. So here one more vague thing is that we don't know this, that what does the edge actually represent? Does it represent that I'm sending an invitation or does it represent I'm accepting an invitation, right? It doesn't make sense. That
It
node
will
0,
represent that. It is ma'am said it as will only exist if 0 accepted the third invitation.
No.
They
I am
accept
just
it
trying to
as
understand that here it is written that a graph is represented where Aij is 1 if and only one, if and
Ma'am,
only if
see
there is an
above, ma'am,
edge
see
from I
above.
to J. Okay.
They
So
mentioned
there is
they
an
didn't
I
no,
from edge from I to J. If these two conditions are satisfied, that J was invited by I. Okay, J accepted I's invitation. So 0 accepted both 3's invitation and 4's invitation. That's why 0 is invalid. Right.
But I can say
There,
that 0 accepted only 4's invitation and rejected 3's invitation.
then this edge wouldn't be there, right? For this edge to exist, these two conditions must be valid. That I to J, there is an edge. That means J was invited by I and J accepted that invitation.
Okay.
Okay.
Okay,
So that means,
for this option to be
yeah,
correct, the
for this
edge
option to be
between
correct,
3 and
this edge
0 should
must
not be
not
there, right?
exist. Yeah, should not exist. Either 3 to 0, it should not exist, or 4 to 0, it should not exist.
Then if we
0
look
cannot
at
take multiple.
option C, 3 invites 4, but 4 doesn't accept the invitation by inviting someone else. But
No,
still there is an edge from 3 to 4.
No. See, understand it like this. 3 invites 4, right? That means 4 accepted the invitation sent by 3. Okay. Now 4 might have sent an invitation to some other person who didn't accept. So there, that means that edge does not exist because the acceptance didn't happen. Whenever we see an edge, it represents that it has been an accepted invitation.
Okay, ma'am.
Okay. So might be 4 sent to 1. Okay. Now if 1 didn't accept it, that means 1 and 4 will not have an edge between them. Now why are the other options wrong? Similarly, see 4 here is taking all of this invitation and accepting. So this one is clearly wrong. And here also, can we see multiple? Well, let's see. So if 3 is the host, right? So 1 is sending to 3.
The
What
host
they
is
have
getting
given?
invited.
Yeah, host is
No,
getting
in this
invited.
option, there
So,
is no host, right? Basically, because if someone is getting
yeah,
invited, they
there is
cannot be
no.
a host. One thing I think that would have made this question better is if they just clearly mentioned that
Yeah,
host
they
is
should
also a
mention
part
it.
of the attendees. Right. I think that would have made it clearer. Okay, let me discuss this with you, sir, once if we should give some extra marks or something for this question.
Ma'am, who makes these questions, if you don't mind?
I don't know exactly who made this one. I didn't. This much I know. I don't know who made
Excuse me,
this.
ma'am.
So
I have a
all the
question.
instructors collectively make these questions.
Yeah.
Excuse me, ma'am. I have a question in this.
Yeah.
Ma'am, there is a point written, right? If a person receives multiple invitations, he can accept at most one of them. So if
Right.
let's suppose we consider the edge that the person has invited. So what does if a person receives multiple invitations, so where is the edge for that? If we just consider edge that the person has accepted, then only we are making an edge. Then where
That
is
is
the
the thing,
person
na?
receives
That
multiple
see,
invitations?
this is the person, 0. This person has received multiple invitations. That's why it has 2 incoming edges. That means 2 invitations he has accepted.
Yes,
Right.
ma'am.
1 is coming from 3, 1 is coming from 4. He has accepted. That's why the edges exist. So that's why this is wrong. In this question, only what I think the one more statement should be added is that host is also part of the graph. Or you can say that the person who doesn't, I mean, something should be mentioned that how to identify the host, or should we think that host is part of the graph or not? Some pointer should be there. Let me discuss it once.
Okay,
Accordingly,
ma'am.
we can make
Sorry, I
something.
need to just have a confirmation one more time.
Hmm.
Like it's
Hmm.
written out as a continuation that all other invitations must be rejected. So if we
Hmm.
just check first option again, so let's
Hmm.
suppose if the person, if we are considering that edge is that the person has accepted, so all
Hmm.
other invitations must be rejected. So of course, from 0 there is only one edge. So
That's
technically,
why this is wrong. No?
hmm,
That's why this is wrong because 0 accepted 2 invitations. Technically, it shouldn't. I mean, according to the question, he shouldn't accept more than 1. Even if he receives more than 1, he should accept only 1. But he accepted 2 invitations. That's the wrong point here.
okay, ma'am, understood.
So C looks correct. Okay, I'll discuss this and I'll let you know on Monday. Okay, what changes we can make in this marks wise also.
ma'am, but
Yeah.
graph should always start with the host. If it is
Yeah,
not
I
started
mean,
with
I
the host,
know. I know that we should always think that host is one of the attendees, right? Because host is going to attend the party. But still, since there was so much confusion in this question, let me just discuss it once. If others in the team also think that
But
we should
it's
give
not
some marks.
specified. That's the problem. That the host is one of these nodes or not.
Yeah, because see, here we can identify the host by seeing that, okay, there is no edge to this particular person, right? Now, look at option D here. Is there an actual violation that we can find if we don't know whether host is part of the attendee list or not? Is any other condition violating? All of them have accepted only one invitation, correct? Only one incoming edge to every node. So this is theoretically correct, right? If I don't know whether host is part of it or not. Is this
Yes,
correct
this
or
is
not?
correct. This is correct
So
if host is not present.
exactly. So if I don't specify that, then some person might think that this option is also correct. If this is just a
Ma'am, but
list of
one is
attendees.
sending invitation to two and three both accepted one invitation, which is wrong.
Okay, this thing. Correct. So
And
3 is
three
sending
no.
to 0 and 4. That means 3 can only do that when 3 is a host.
And
Right. And
one
if
and
3 is a host,
it
then 1 cannot send to 3. That is one point. Lots of
and ma'am,
points in
if
this.
the graph is only between invited, it will be
But
a
I
straight
can say
graph.
that one is also the host. So
Then
the
0
best
cannot
conclusion
send
is
to
that
1 because see, 1 is also sending to 2 and 3. That means in that respect, 1 can also be considered the host. But similarly, 0 is sending to 1, which is wrong.
yes. So the best explanation is that this option is only correct if there is no host in this nodes.
Yeah. So this option becomes correct if there are no hosts. But
Ma'am, but
we are
invited send
thinking that
only
But we have already assumed that there is a host. So
there's a
that
host.
that's why
Yeah.
this
The
option won't be
person who
correct.
made the question, their thought process was that the student will think that host is part of the attendees, right? But now some students didn't think that. That's why all this confusion arises. So it is valid. I mean, some people might not think that if you have not specified that exact line, but let me discuss with everyone. Okay, by Monday, we'll let you know what we can do about this question.
ma'am, can you show
Yeah.
the question?
Show the question. Yeah.
And same thing we can say for option one.
Ma'am,
Option
same
1.
here you
Yeah, if the
mentioned
host is
that
not
if a
specified.
invitee accepts the invitation, he can exactly invite one other person. Exactly one other person. If
Uh,
this graph is between invitees, then one cannot invite two persons.
yeah. So now see, if somebody thinks that host is not part of it, right? Then he will think all of those options are wrong. Wherever you see that more than one invitations are being sent and you don't think that host is part of the graph, then you will think all the options are wrong. That is also going to be a wrong approach. I'm just saying that might be beneficial if we added some extra information to this question. That is my point of view. Now, others might think differently. I just have to discuss with everyone. Then we can come to a conclusion what to do about it. Right?
Excuse me, ma'am.
Yeah.
I have doubt in question number 11.
11. Okay. Any other doubts others have in any other GA question?
This one, question 11.
Yeah. So this is a part question, right? For that, I have to check question 10 first.
Yes, ma'am.
Let's check. So A variable is having 0, B variable is having empty list. For each are in rows of collab.
And
Okay.
actually, you
This
have
is
to check
also
question
part.
4
Oh,
because
these
it's
are
a
all
long
part
part.
questions.
Yeah.
God, that's a lot. So if I check question 4, will I directly be able to do question 10? 4 to 11 are all connected.
Yes, yes. If you
Yes,
check
ma'am.
4, then you
Yes.
will be able to do 10.
Okay,
It's
okay,
like
let me
matching
check.
the options.
Okay. So statement is saying using the matrix collab computed again previous question. So I cannot do from 4 also. I have to check from 3.
And
This
this is
one.
so dangerous, like, to have so many connected questions, because if you miss the thinking in the first part, everything else you will get wrong.
Yeah, so we have given such questions in some of the weeks to prepare you for such questions in end term, because in some weeks there are no connected questions. In this week we have so many connected questions because in end term when usually we give question from graph matrix part, those questions are connected.
Okay.
number 2 or 3 questions will be connected. Okay, that's fine, just for practice. Okay, let's see what is happening here. The following table contains information regarding books in a library. Each row in the table corresponds to a book and is authored by exactly 2 authors with equal contributions from both. So there is a pool of n authors, each author being assigned a unique index between 0 and n-1. There are m books in total. That means every book has a co-author, right? By exactly 2 authors. So that's represented here. There are m number of books, so S number ranges from 0 to m-1. So table is represented by a dictionary named books. Okay. And the keys as serial numbers and values as the corresponding list of authors. Okay. That means serial number, these are the keys and these are the values. So values are stored as list of authors. So for every corresponding S number, there is a corresponding list of author 1, author 2. So assume that book has already been computed. For the example, we have book 040. This means that book with S number 0 has been written by author 4 and author 0. So graph G is generated from this table. Each node corresponds to an author. There is an edge between authors I and J if and only if they have collaborated on a book. Okay. Given a pair of authors I and J with I not equal to J, what does the value collab IJ represent at the end of execution? All right. Assume that number of authors n is given to you. So we have to find what is collab IJ when I is not equal to J. So collab is a matrix, first of all, n cross n is number of authors. For each I in keys of books, that is each unique book, that is the key. We check if author 1, okay, we assign to author 1 the first of books of I, that is the first in the list, author 1, second in the list is author 2. Collab of author 1, author 2 is equal to collab of author 1, author 2 plus 1. Okay, this doesn't, what does this mean basically? Collab of IJ where IJ is not equal means collab of IJ will store the number of books that these two authors have written together. Correct. That is clear from this, right? Because every time we find such a book, we are incrementing by 1 in both author 2, author 1 and author 2, author 1, author 2, because these two entries are basically same. These two are co-authors. So every time we find a book that has been written by these two authors, we are incrementing the entries by 1. That means in collab dictionary, IJ value represents two authors who are not same author, obviously, two unique authors, and the corresponding value is the number of books they have written
Ma'am,
together.
excuse me.
Yeah.
We are doing this in a matrix.
Yeah, this is a collab IJ is a matrix, right? We're creating the matrix.
Okay, ma'am.
So author 1, for author 1, see collab IJ, what is the structure of that matrix? There is n cross n, right? That means n authors are the outer keys, and then for each of those authors, we have a list of, or we can say a nested dictionary of authors who are co-authors with them. That means if author 1 is co-author with author 2 is also co-author with author 1, right? So every time we find a book written by author 1 and author 2, we have to increment the entries in both of these cells. So collab of IJ represents that. Now coming to the question. Okay, this also I have to study, right? To do question 11.
Yes, ma'am.
Question
So
11.
using
Yes,
No,
ma'am.
ma'am, actually, we just have to see the code and identify what the variable is storing and then come to this part to recheck with the options.
that means this question 10 code I have to check, right?
Yeah,
Yes.
yeah.
Yes.
Okay, so A variable is assigned 0, B variable is empty list for each R in rows of collab. That means each unique author name. Count is initialized to 0 for every iteration. Okay, this one is ending here. This is a typo. This is supposed to be an empty bracket, right?
Yeah, that's a typo, I think.
Okay,
Empty
Because
bracket.
the back bracket would have been closed at the end.
right, right. Anyways, so count 0 for again nested iteration for each scene columns of collab. So we are checking for 2 unique authors if they have written at least one book together. So if the entry is greater than 0 means what? That authors R and C have written at least one book together, right? Then count will be incremented. Again, for every author, we are going to check with every other author. That is the nested loop doing, right? So for RC, for every author R, count will be incremented how many times? Let's say an author has
As much times
written,
as he has collaborated.
correct. So as many times as he has collaborated with other authors. So count is storing that. Now, once this inner for each executes, then we come out of the inner for each block. And if count is equal to 1, that means if he has collaborated with only one other author, then A var is set to A var plus 1 and B var is set to B var plus this. That means this R is now appended to B var, right? So it is asking what is the correct option for variable A var. So that is, this data is given where?
Storing
In that
number of
question 4.
authors who have collaborated only in one book.
Yeah, that is what AVAR is storing, but this is an NAT question. That means there is a data given. Where is that given? In question 4.
No, the option is given in before actually. Like that table which you just saw.
Yeah. So
This one.
maximum, yeah. Okay. So maximum number
It will
of
be option
collaborators,
6.
number of authors who have exactly one collaborator. This will be the one, right? This is AVAR.
Yes, yes.
So
Yes.
7 is the answer. And he is asking question 11. 11
Yeah.
is asking what is
How
the
the
correct option for.
how the answer same of question 11?
What did I say? What does AVAR represent?
No,
AVAR is being in.
B variable.
Yeah, I am coming to that, right? I haven't discussed yet. What is the correct option for BVAR? So BVAR is containing which authors? The authors who have collaborated with only one other author, right?
Yeah.
That's why the count is equal to 1. So only those authors are being stored in BVAR. So check in this list that is given.
List of unique authors. I mean collaborators.
List of
List of
authors who have
Number
just one
6.
collaborator. So that is 6. This is
Yes.
BVAR. So 6 such unique authors are there. See, just decoding it makes it very simple. These are linked, but these are very simple questions. In term might
Ma'am,
be a bit more difficult.
can you
Yeah.
help me understand the difference between list of authors who have just one collaborator and exactly one collaborator?
Hmm.
What
So
is the
if
difference?
it is exactly 1, then count will be equal to 1, right? And just one and exactly one are same. Just one collaborator, exactly one collaborator is same. Difference is between at least one or at most one and exactly one.
I think she is missing the first word. That's more important, like the number of authors and the list of
And the
authors.
list number and list she's missing it.
The
Okay.
list means that if the names of the authors.
Yeah, okay, I understand. See, A where represents how many such authors are there, okay, who have only one collaborator. And B where is the list of those authors who have only one collaborator. So these two people, right? Look, A where is being incremented when? Every time you check for one author R, you check with every other author that whether they have collaborated. If the count is exactly equal to 1, then you increment A var by 1. That means you have found one such author who has only one collaborator. And B var, in B var you append the name of this particular author. That's the difference, right?
Okay. Okay. So BVAR is the list and AVAR
B var
is
is the list. A var is the variable.
okay.
A var is the count basically of such authors.
Okay.
Can you do last question? It's related to question 4. And here it's mentioned that the host is not part of the attendees.
Okay, this is that question.
Yeah.
Continuing with the previous question, for a pair of attendees ij other than the host, we say that, okay, pair of attendees ij other than the host, we say that I is the ancestor of j if their messages are identical and I has accepted the invitation before j. That means I has sent to j basically. So note that each invitation sent out by the host is a unique text message. Assume that matrix A that represents the graph has already been computed. Fine. His ancestor is a procedure that accepts the matrix A and two attendees I and J. Okay. Other than the host. Okay. I and J are definitely not the host as input, and I is not equal to J, and returns true if I is the ancestor of J, false otherwise. Okay. So we just have to check whether I is the ancestor of J. That means I is the one who sent the invitation to J, and we know for sure I and J are not the host, right? So we have to fill in this code. So first, what is happening inside K variable? I have stored I, flag has been set to true. So while flag is true, so in every iteration, flag is being set to false for each C in columns of A. Columns of A contain what? The attendees only, right? Okay, now I have one question. That means columns of A will also contain the host, because A matrix will contain the host, right? In the graph itself, if host is assumed that host is one of the attendees, then in the graph A is the host is present. Then in adjacency matrix also host should be present.
Yes, ma'am.
So
Yes.
for each C in columns of A, that means I will go through all attendees along with the host. But I and J are not the host. That's all we know. So now you go through each of those attendees and there is some code. And we will return true. So there will be a return statement true somewhere in this missing code when I can conclusively prove that I is the ancestor of J. That means there should be an edge from I to J, right? From I to J, there is definitely an edge. And we also have to prove that I received the invitation before J. Okay, let's see what are the options. First option is saying if A of K and C is equal to 1. That means if there is an edge from K to C. K is nothing but your I, right? And C is the current attendee I'm checking for. So if there is an edge from K to C, and if C is equal to J, then return true. So what does this mean? K to C, there is an edge. What does this mean?
C has
That K,
accepted the
I to
invitation.
J, there's an edge.
that means C has accepted the invitation sent by K, right?
Yes, ma'am.
And C, if C is equal to current J, that means the person that I am working with. I'm trying to find if I is ancestor of J. Now J will definitely be present in this list of keys, right? C
Yes, ma'am.
in this list of columns. So
But
J
it's
will be
written
present.
C is double equal to J, but
Yeah. So if
K is not
C,
double equal to I.
no, K is already been assigned, right? In the beginning, K has been assigned to I. K is already I. Now we are seeing that who are the people to whom K has sent invitation. So if we find such a C to whom K has sent the invitation and we find that C itself is J, then return true. That means an invitation to J has been sent by I because K is nothing but I, C is nothing but J. And then they're saying, then you assign K this value C, that is J. Now J is being assigned to K and then exit loop. So if when will I come to these two statements? If C is not J, right? If C is some other value, then next K is being changed to C. Why K is being changed to C? I have to check for this only. I have to check for I only, I to J.
And
This statement I don't think is correct. Why should K be set to C, right? Even if this current C is not equal to J, then also I need to check this same K with the other C values because K
Yes,
is I.
it's wrong.
This looks wrong to me. Let's check the other options. Again, up to this, it is same. It is saying then you set flag to true and exit loop. Okay, but see one thing in the code, flag is being set to false immediately. That means flag has to be set to true for the next iteration. Okay, so flag will be set to false once, and then inside it there will be multiple iterations where I check for every C value. So flag is set to true and then exit loop, they're saying. So if I don't find that C is matching with any J, So what happens if I see that K to J, there is no invitation. That means no C matches with J. That means J is not part of the graph. That means what? That I and J are not, I is not the ancestor of J. Right? If no C, if this condition is not true for any J, what does this imply? That J is not part of the graph. That where there can be an edge from I to J, right? Because K is I. So
No,
if,
ma'am, it will, won't it be like the current person we are working with is
Like,
not equal to the J?
no, I'm saying that if there are no such C's that are equal to J, after
Ma'am,
doing
but
all
there
of the
will be.
iterations, wait 1 second. I'm just trying to understand why set, I mean, what is the point of setting flag to true? Why will I need to go back to the while loop? I mean, one iteration of while loop is not enough. That means multiple iterations will happen. Mm,
Ma'am, here while loop will only run when flag is set to true. But
Flag is
at
set
the
to true,
start
but
of the while
after the
loop, we are
first,
setting to
yeah,
false. And if we
yeah.
not find the answer in for each loop, we have to set to it again true. So we can again work with the while.
No, that is my question. That first the
do we
K is
even
being
need to
assigned I, right?
like, do we even need to set the value to true because it's inside the for loop?
Yeah, that's my question. Because K is already being set to I, and from I to J, we only want to find, right, if there is an edge.
Now,
So
if we
that
set
can be
it,
done in,
if we set it as true, then it will run infinite, I
if flag is
guess.
set to true.
Yes,
No,
Yes.
ma'am.
see,
It
my
will run.
question is different. My question is that since I'm trying to find whether I is an ancestor of J, that means if I to J, there is an edge. That's what I'm trying to find, right? So that
Yes,
I
ma'am.
can do in one iteration of the while loop also, right? Because see, I am going through all of the C values. That means all column values anyway. And my K is already assigned as I. That means at some point I'm bound to intersect with J. One of these C values is J, right? So there only I can find out whether there is an edge or not. And I can directly return. Then why do I need another iteration of the flag, of the while loop? That's the question.
Ma'am, can you show us the
Basically, we don't need the while loop.
I mean, I can directly do it, right? I can directly set, I mean,
Yeah.
all of this I can just ignore and I can say that if I send K to I and then I check with that. I mean, with that K value, if AKC is equal to 1 and C is equal to J. So what is the point of the while? Okay, let me see still what are the options. We have to check what is given to us. So if this is a correct option, if I say this is a correct option, so when is this going to be executed? For every C value
This
that
is
we
the correct.
encounter.
I also thought this was
Okay,
the
okay,
correct
okay.
option initially, but
See,
it
see.
will like do infinite looping.
Basically, what this option does is that let's say my I and J, let's take some arbitrary values. Okay, let's say I is 1 and I want to find for J 5. Okay. But I has to first check with 1, 2, 3, 4, and then it will come to 5, right? So the C values will be K is 1. C values will be what? 1, 2, 3, 4. All of these C values will not find a match. Okay, let's say they don't find a match because C is not equal to J. Correct. So for all of these iterations, what will happen? For all of these iterations, if there is an edge, let's say there is also an edge, can there be an edge from I to any other node? If there is an edge from I to J, can there be an edge to from I to any other node? If I
no,
is
ma'am.
strictly an attendee? No. Right. So that's the point of this option. See, K to C, if there is an edge, okay, that edge has to belong to J if there is an edge from I to J and no one else, right? But if there is no edge, let's say from, I find that there is an edge from 1 to 2. Okay, then in that case, this will be correct. This will be incorrect. So I won't be returning the true because 2 is not equal to 5. Then I will come and set flag to true and exit loop. That is exit the current iteration and then go back for the next while iteration. That means you come out of the for loop, but go back to the while loop for the next iteration of while. But next iteration of while when you do also, will I get a different result? I'm doing all the same things, right? K is not being updated in this option. K is not being updated anywhere. In this option, K was being updated. So why is it this option not correct? Because I to J I want to find, right? There is also one more thing that I will also be one of the C's. Both
Ma'am,
I
can
and
you
J are in the C. Let's just see what they have given. They are saying that this option is correct. That means if K to C you find an edge and that edge that C is J itself, that means I to J there is an edge, so you return true. Fine. If
Here
not,
again, K is becoming C.
yeah, so they are saying, let's say now let's do our example that I is 1 and my J that I want to find is 5. Okay. So first I have to go like this 1, 2, 3, 4, all the J values, all the C values, and then I'll reach 5. Okay. So first let's check if 1 to 2 there is an edge, right? So this is 1, K is 1, C is 2. If there is an edge, okay, then is C equals to J? Our J is 5. No, right? Then return statement will not work. K becomes what? K equals to C. So what is C?
the current value?
C is
Current value.
the,
That means now K becomes 2.
but it changes the entire thing, right?
Ma'am,
Yeah,
can
I'm
you
Actually,
trying
repeat
to.
it's
the previous
asking,
question?
it's asking about I. Now I's value altered.
Yeah, that's what I'm trying to understand. That I's value is being altered. Then how are we saying that
So
I
there's
received?
no way right now to find the
Let's
what do we
see
say,
what they
edge.
have given as the explanation. Let's read. The basic idea behind this solution is that I is an ancestor of J if we start from I in the graph and read. Okay. They are saying that I might not be a direct ancestor. I might have invited some other person who invited J. And understood. They're saying that from I there might be n number of people, and then somehow you reach J through those invitations. So I is some ancestor. I is not a direct ancestor. So we have to move along these edges. So we have to see that from I can go to some other, from that I can go to some other K2. Then from K2 I might reach J. But then also I becomes an ancestor of J. This is the logic. We were thinking that it is strictly I to J. So then they're saying that since I is not the host, there will be at most one
Well,
outgoing
this
edge
should
from
be
I.
another question error. Like it's again very vague.
Let's see in the question, is it any way to understand by reading it? Other than the host. So
It's
for
only
pair of
written
identities
ancestor.
IJ, I is the ancestor of J if their messages are identical. Hmm. That means I sends, let's say I receive the invitation that has some unique message, right? Then the person that I sends an invitation to will have that same message. Then again, that person can send an invitation to another person. Is
Yes,
it
ma'am.
like that? So
Yes,
that
ma'am. There
person
might
also has identical message like this.
they
Okay,
will
and we
forward
have
the same message,
to,
ma'am. They will forward the same message.
yeah, it's over the same message. Hmm. Its graph is like a host is inviting, let's say, n number of people, then those n number of people might also be inviting n number of people through these edges, right? So if messages are identical and I has accepted the invitation before J, note that each invitation sent out by the host is a unique text. So ancestor. So it is written that I is the ancestor of J, but it is not written that I is direct ancestor. Hmm. Could be. I mean, could be. Maybe we could have added more information. Because I also assume that I and J are direct ancestors, right? So it is not impossible for student to also assume that. Okay, these two questions let me consider once with the team. What they say, let's see. Anyways, if you do not understand the first question and this question, I mean, both of them could have a chance at ambiguity, right? So,
There's one more
cannot.
point is that in the very first line of this question, it said that a host is not considered.
Host is not
So
considered. That's true.
from that we can assume that in the previous question, the host was also not considered.
Yeah, I mean, no. Then again, some people will say that in this question we are specifying that host is not considered. Other question it was not specified. That means host was considered. There can be a lot of ambiguity around these things, right? If there is not a proper statement. Okay, these two questions let me consider once. On Monday, we'll let you know about these two. These are connected questions. Huh? Let's take these two into account. Now only I'll talk to Piyush sir and see about these two questions. Okay, any other question you have doubt in this assignment?
No.
Okay, then these two, right? Then on Monday, whoever takes the class, they will let you know that what is happening. And again, about the solutions also, if we change anything, we'll let you know whatever happens. So on Monday, then should I tell the instructor to take a week 10 session? Because if week 9 you have no other doubts, then we should do week 10.
Yes,
Yes, ma'am.
ma'am.
That
Ma'am,
is
Yes,
okay
ma'am.
with everyone.
could you please tell to the whoever manages the calendars, like tell them to specify that which class will happen on, like suppose today was week 9.
Okay, so you
I
want
some student
in the
yes.
specification that what week we are covering in that session, right?
What week and what topic? Like so for
Yeah,
Like
example in
practice
like
maths the
assignment or what?
yes, in maths, the instructors generally do not cover the entire maths topic in one session. They take two sessions mostly.
Right.
So like
So
that.
like that we can just so we
Or
can
maybe it's
mention
a
that
doubt
what is the
session.
right.
Yeah.
So we'll mention what is the summary session, what is PA session, what is doubt session, right? That
No,
will be
it's
very
already
clear.
mentioned in TA and instructor session.
No,
I'm
no.
just saying.
PA, that is practice assignment. So in which session we discuss
Oh,
practice,
okay.
in
Okay.
which we do summary. These things, if we classify, it will be easier for you, right?
Yeah.
yes, ma'am, that
Okay.
would be great.
All right. So this is also one point. I let them know. All right. And next Monday session, you want week 10 summary, right?
Yes, ma'am.
Okay. All right then. Thank you. Thanks for joining. These two questions I'll definitely discuss and let you know on Monday. Okay.
Yeah, ma'am.
Thank you, ma'am. Good night, ma'am.
Thank you.
Good night, ma'am.
Thank you. Have a good night, ma'am.
Good night, ma'am.
Thanks.